All right, so we're going to go over these Chapter 7 problems. I'm going to do 7-11 because this covers pretty much all of the basics that this chapter covers. I'm going to do 11 and 12, maybe 15. All right, so 7-11. For this one, we have two equations, right? And this is similar to something that you saw on the first exam, those tension equations. So we pretty much have a 100-pound weight, and we're given the two following equations. We're given 0.6 T1 plus 0.8 T2, and this is equal to 100. 0.8 T1 minus 0.6 T2, this equals 0. So part A asks us to write this as a system of equations in matrix form. Part B asks us to find T1 and T2 using matrix algebra, and part C tells us to use Cramer's rule. So how do we write this in terms of matrix form? Right here. We have two variables, T1 and T2, and we have the coefficients of those ones, which are 0.6, 0.8, 0.8, negative 0.6. So we can then rewrite these two equations in matrix form like the following. We would take the coefficients, and we would just kind of generate a matrix that you would see around here, but without the variable t. So we would have 0.6, 0.8, 0.8, and negative 0.6. And the variables for this are T1 and T2. And this is equal to 100 and 0. So we could think of this, if we were to make a general equation, we could think of this as A, we can make this our variables, but we'll call it X, and we'll call this B. So that we have the following equation. We can represent this system of equation as one linear equation as AX is equal to B. Now let's go to part B. Part B says we want to find T, the matrix T, which we have matrix A. Let me redo this. We have A, our variable matrix, our variable vector T is equal to B, right? So in order to find T, we need T to be equal to the inverse of A times B. So in order to do this, we need to find the inverse of A. The inverse of A is found first by finding the determinant, and then subtracting or multiplying A and D. So if we have a general matrix, we'll call this element A, this element B, this element C, this element D. Then, and this is matrix A, then A inverse is equal to A times D, D not B, A times D minus B times C over the determinant of A. So we'll find the determinant, and then we'll solve for the inverse matrix. So let's find the determinant of A. Determinant of A, I'm sorry, I actually solved for the determinant right here. This, what you do to find the inverse is you multiply the inverse by the, you would take the, we should call it the inverse matrix, and this will be over the determinant of A. So forget what I just said. So we would then rewrite this now as the inverse as A times, nope, it would be D, you flip these two, and you switch the signs on B and C. So it would be D, A, minus B, minus C, over the determinant of A. And this is your equation for the inverse. So let's find the determinant of A. The determinant of A is equal to A times D minus B times C. So this is equal to 0.6 times negative 0.6 minus 0.8 times 0.8. So this is equal to, it comes out to be 0.1. This is equal to 0.6 times negative 0.6 is negative 0.36 minus 0.8 times 0.8 is equal to 0.64, but it's a negative, so it's plus 0.64. And then this is just equal to 0.64 minus 0.36, which is 0.28. And this is the determinant. So now the inverse of A is represented as D, A minus B minus C over the determinant of A. So this is equal to, this will be negative 0.6, 0.6 minus 0.8. Hold up. I lied. This is a negative. This is a point positive, so this is negative right here. And this is equal to 1. So the determinant is equal to 1. So now we have to, coming back to this, we have negative 0.8 and negative 0.8, and this is over 1. So this is just equal to our inverse matrix. So this is 0.06 minus 0.8, 0.6, and minus 0.8. So now we can find T as equal to minus 1 of our, this minus 1 comes from our inverse, 0.6 minus 0.8 minus 0.8, 0.6 times B, which we know is 100 and 0. So when we solve for this now, we multiply this term by that term, and this term, and that term, and you add them together so that we have T is equal to negative 0.6 times 100 plus 0.8 times 0, and then negative 0.8 times 100 plus 0.6 times 0. So this is equal to negative 60, and negative 80. But because we have the negative 1 in front, this becomes positive and positive, so it's 60 and 80. Now, the third part of this problem, part C, tells us to use the same thing, find T, using Cramer's rule. So we can find this T1 as equal to 100, 0.8, 0, and negative 0.6. And what we do in this term is we take our B matrix for T1, we take our B, this is also over the determinant of A. So if we want to find the first variable of our variable vector, we take our B term and we put B here, and we take our first two coefficients of our original matrix, or the second position of our original matrix as A, but it's not fully A, it's a segmented, which I'll say A2, the second column of A, over the determinant of A. So we can rewrite this as this up here. Now, in order to solve this, we take the determinant of this whole thing. So we multiply these two and subtract it from these two multiplied together, so that T1 is equal to 100 times 0.6 minus 0 times 0.8. And this term is negative, so that cancels. And this is over the determinant of A, which we know from the previous problem is -1. So now T1 is just equal to 60. Yeah, because this is negative. This is a negative 0.6, right, from right there. So this becomes negative 60 divided by -1, which is going to give us a positive 60 for T1. So we found our first variable, T1, is equal to 60 using Cramer's rule. Now the next one, if we want to find T2, T2 is equal to the first column in A1 times B, or augmented with B, over the determinant of A. So this is equal to the matrix 0.6, 0.8, 100, and 0 over the determinant of A, which we know is -1. So now we take the determinant of this whole thing in order to find T2. So this is just equal to 0.6 times 0 minus 100 times 0.8 divided by -1, which equals -80 divided by -1, where T2 is just equal to 80. So we found the same two values that we found in the previous part of 60 and 80 using Cramer's rule in a quicker way, in a quicker manner. Alright, now 7, 11, and 15 are similar, or 12 and 15 are similar to 11, so I'll just do 15 because the numbers are a little harder, and then we can answer questions about MATLAB or whatever. So for 7, 15, we're given two equations, 0.866 F1 is equal to F2, and we're given 0.5 F1 is equal to 750. So the first thing we're asked is to rewrite this in write the system of equations in matrix form. So we're going to have to rewrite our matrix, and then we're going to have to solve it using matrix algebra and then Cramer's rule. So let's rewrite these two equations so that we can have the two variables over top of each other, and it'll make it easier to see. So if we write the first one as 0.866 F1 minus F2 is equal to 0, that will be equation 1. And then we would rewrite equation 2. Actually, we can leave equation 2 the same. The only thing I want to add is a 0 F2 term so that we can see the matrix a little easier. So we can rewrite this now as 0.866 minus 1, 0.50 F1, F2, and this is equal to B, which is 0, and 750. So that's pretty easy, and we can see that. Let's go to part B. Part B says now let's find this. Let's find F, which is this variable vector F. Let's find that by taking the inverse of A1 and multiplying that to B. So first thing we do is find the determinant of A, which is equal to A times D, not B. A times D minus B times C. And this is equal to, going back to our previous matrix, would be 0.866 times 0. So it would be 0.866 times 0 minus 0.5 times negative 1. 0.5 times negative 1. So this is equal to negative or positive 0.5. Now, the complete inverse matrix is just equal to, we change positions of A and D, so this will be 0 and 0.866, and we change the signs of B and C. So this will be positive 1 and negative 0.5, and all of this is divided by 0.5, so that we can actually rewrite this matrix if we want. Actually, let's not worry about that right now. Let's just solve for F. So F is equal to A inverse times B, so that we have A inverse, which is equal to 1 over 0.5 times 0 to 1, negative 0.5, 0.866, multiply this by B, where B is 0 and 750. And once we do all of the matrix multiplication, so that times that times that, we come out with a final answer that looks like this. It would be 1 over 0.5 times 750 and 650, which comes out to be 1,500, 1,300, which equals F. So that this will be, so F1 is equal to 1,500 and F2 is equal to 1,300. Now we're going to do the same procedure using Cramer's rule. So C, we know that we generate this by having, we'll have B in the first, we'll have the first column of A, I'm sorry, not A, this will be B. We have B and the second column of A as our matrix, and we want to find the determinant of that over the determinant of A. So this is equal to 0, 750, minus 1, 0. This is over the determinant of A, which we found as 0.5. And this is just equal to 0 times 0 minus 750 times negative 1. And that's over 0.5. And this is equal to 1,500, which is the same, and this is F1. And this is the same as what we found on the previous page. The F1, where are we at? Right here. F1 is 1,500. And then you would do the same thing for F2, but F2 now has the first column of A1 and B. Find the determinant of, while this is all over the determinant of A, so we would just rewrite this now as 0.866, 0.5 over 0.5, and this is 750. This is now equal to 0.866 times 750 minus 0, because 0 times 0.5 is 0, and then we divide this by 0.5. Once we crunch the numbers, this gives us 1300 equal to F2. And this is the same thing that we get by doing the matrix solution.